Okay, so let's see what happens if we try to solve x plus 1 over x equals just some number a. And we think the minimum value of a is 2. We think a can't be less than 2, right?
Where if x is an integer.
X is any number. Remember the graph?
Yeah.
Okay, there was, if x is positive at least, we didn't think that there couldn't be any a that was less than 2. Right? Do you remember that?
Yeah, that seems right.
Okay, so let's see. I multiplied, do exactly what you did. X squared plus 1 equals ax. Okay. Bring this over to the other side. X squared minus ax plus 1 equals 0. Okay. What's the part that's under the square root in the quadratic formula?
Well, it's the square root of a squared.
Okay, it'd be square root of a squared. So maybe I should have called it b. That's all right. A squared
Minus 4.
minus 4. Okay. And what was the minimum value we saw so if a was gonna be positive, what's the minimum value that makes this square root have an answer? Have a real answer?
A squared is 4.
Okay. So
4 minus 4 is 0.
So what would a be if a squared
A
is 4?
has 3 too.
Okay. What would happen if a was 1, say?
Well, then you get into complex numbers.
Right, so no real solutions. In fact, if a is positive and less than 2, what's going to be inside of that square root is going to be an imaginary number. Right, so you can see, that's one way you can see that this never has a value lower than 2, which is actually pretty interesting. That's another interesting thing about this function, x plus 1 over x. So that's a neat problem. It shows that, what was it, 4?
Yeah.
Okay, if you go to the quadratic formula, messy. Right? But if you had, this function had a very special property that you could square it, so there was another route that was simple. It's kind of a cool problem actually though. Neat algebra problem. Good work.